Okay, let's see. Oh, yes, okay. Now we're to the difficult ones. Okay, so an 8.3 kilogram rocket, 5.2 kilograms of which is fuel. Okay, so the first thing I want to do is I want to figure out the initial mass. The initial mass is 8.3, right? The final mass is, so let's call that initial, okay? The final mass is 8.3 minus 5.2 because it's going to, most of that mass, of course, is fuel, right? A well-designed rocket is mostly fuel by mass. So 8.3 minus 5.2. Here's what's left. So when the last molecules of fuel are being burned, the thing has a mass of 3.1 kilograms, right? Okay. The next thing, and this is the thing that everybody messes up, okay, is they got to figure out the thrust. And this thrust is going to stay the same. So we're going to go force times time is mass times change in velocity, okay? Now, for this, remember, this mass has to be the mass of fuel burned in this time. It's not the rocket's initial mass. It's not the final mass. It's the mass of the fuel. This is the most important thing, okay? So that's 5.2, right? Exhaust velocity is 610. The time that it takes that fuel to burn is 12 seconds. And we're solving for the force, okay? Just make sure that that is the fuel. It's not the initial mass. It's not the final mass. It's the fuel mass, okay? Okay, 5.2 times 610. Hopefully I emphasized that enough. And then divide it by 12. So the thrust of the rocket, okay, the force that the rocket's exerting upward is 264.3 bar. All right, now we've got the tricky business of solving for the initial and final accelerations. Okay, so the initial, right, is we got a mass of 8.3. So the force down is 8.3 times 9.8. So 8.3 times 9.8 is 81.34. Okay, the force upward is our 264.3 bar. So when we set up our expression, we go positive 264.3 bar minus the force of gravity, 81.34, equals the mass, 8.3, times 8. Okay, so now we're going to do this. So 264, that guy, minus this guy, is 182.99, and then divide by, that's the net force, right? So divide by 8.3. And I get 22.0 meters per second. Okay. So the acceleration, the initial acceleration, AI, okay, is 22.0 meters per second squared. All right, the final is going to be a whole lot more because the rocket has less force of gravity opposing it, and it'll also have less inertia. Okay, so let's draw a picture of this guy. It's important that you draw a good picture, right? Okay, now the mass is 3.1. Okay, so the force downward is going to be 3.1 times 9.8. That's 30.38. We're going to imagine that the force upward doesn't change. It's still going to be 264.3 bar. You guys are rocket scientists now, aren't you? All right, and then we set this up. And the only thing that changes is that the thrust stays the same. So 264.3 bar, that's a 4. Even though it tried to switch teams and turn into a 9. Okay, minus the force of gravity, so 30.38. And then that equals 3.1 times A. So this minus this, there it is. Okay, minus the number we just got. It's 233.95 divided by 3.1 is 75.46, so 75.5 meters per second. So the final acceleration is 75.5 meters per second squared. Okay. So this, by the way, of all the steps, this is the one that's the most often messed up. I think it's just because there's so many masses running around that people just don't know what to do. Okay, once you get to this part, we've already done this. You guys have already gotten A's on this test. So anyway, happy hunting.